Morning, students. Hello. Can you hear me? Can you see the screen? Let me see this here. Um, Someone need to answer. Let me know you can hear and see the screen. Nobody's hearing me. What's happening here? Brandon, can you hear me? Danica? Nobody's hearing. Najee? Shane McCullough, can you hear me? Zion Gooden, can you hear me?
Yes, sir. I can hear you.
You can see the screen as well?
Yes,
Yes,
sir.
sir.
Well, nobody will answer an hour ago. I want to come over there and beat all of you know. All right. I'm not so 100% today. I have a little bit of sniffle, as maybe you can hear my voice. But that won't stop what we have to do. So I'm going to do some revision work on this topic of coordinate geometry. I think I'm going to give you the classwork tomorrow and Monday. And move on to a new topic on Wednesday. Alright? Which is linear programming on Wednesday. Inequalities and linear programming. So brace yourself for the class activity tomorrow. Alright, so we're doing a couple questions from past papers, questions that I sent in the group. I see some person sending me solutions. With a few mistakes here and there. Great thing is that when you do the questions, you learn from your mistakes. So this paper is the January 2017 exam paper. And this is number 4B. Number 4B, I think it is. Yes, number 4 part B. It's a coordinate geometry. What you'll find is that these questions are testing the same things that we are covering in class. All right, so the question gives us these 2 points, P and Q. And they are endpoints of a line segment PQ. And I want us to determine, firstly, the gradient of that line PQ. Remember, gradient is rise over run, which is difference in y, or difference in x. So the gradient, which is written with a common m, of PQ is equal to the difference in y, over the difference in x, because it is rise over run. And you calculate the rise by taking the difference in the 2 y values between the 2 points and the difference in the 2 x values. So these are the y values that we're starting with. You're taking that difference first. So it's like the 7 minus a -1 first. That's the difference in the y values on top. That's 7 minus, and then this is a -1 we're subtracting. That minus becomes a plus. Let's put a plus there in red. Alright? And then in the run is the difference in the 2 x values. So this x value minus this x value. But what is important is this. Because I use this y value to minus this y value, when I'm doing the difference in x, which is a run, I have to come back to this point and use this x value minus this x value. So the same direction I subtract the y values, this minus this, I have to subtract the x values the same direction, because gradient has a direction component to it. And if you reverse the direction of how you subtract the values, you're going to get the wrong sign. What is supposed to be positive is going to come out negative, and vice versa. So, because I did, as I said, this y value minus this y value, I now have to do this x value minus this x value, which is now 2 minus 6. Alright, and you simplify this down. This becomes a 7 plus 1 is 8. Divided by 2 minus 6 is negative 4. Then 8 divided by negative 4 is negative 2. And so this is the answer right here. Negative 2 is the gradient of that line PQ. Alright, everybody good with that? Everybody okay?
Sir.
That's a yes? All right, you is
Yes,
sir.
sir.
Alright, good. Alright, so that's the answer for that part. Next part wants the coordinates of the midpoint of PQ. Remember, midpoint is like an average point. Just remember that. Alright, that's an easy way to remember how you find the midpoint. Let me write down these coordinates and carry them on the next page. 2, 7. Alright, so if you remember that midpoint is like an average point, then you can calculate the midpoint easily by thinking of it as an average point. So you're going to average the x values and average the y values. So the midpoint, we want to call it capital M. So it's common M up here for gradient, but it's capital M we're going to use for midpoint. Right? So the midpoint of PQ, we're calling it capital M. And it is the average of the x values and average of the y values, given the midpoint. So the sum of the x values divided by 2, and the sum of the y values divided by 2. So you're averaging these two x values first. That's the 6 and the 2, right? Average those two x values first. So it's 6 plus 2 divided by 2, and then you're averaging these two y values. That is the negative 1 and the 7. You're averaging them. So it's negative 1 plus 7 divided by 2. And you simplify. So the midpoint, this becomes 8 over 2, which is 4. And this becomes 7 minus 1 is 6. 6 divided by 2 is 3. So these are the coordinates of the midpoint. 4, 3. Alright? So we have that. Next part now is something that we did in class the other day. You see? There was the perpendicular bisector. There was the equation of the perpendicular bisector of PQ. And we did this in class the other day. So you see, what I give you in class is what is on the exam papers. Hope you're noticing that for yourself. Let's do a little sketch of this situation so we can reference it and just to be clear on what it is. Alright? I'm just give you a little visual of it, of what it is. So 6 minus 1, 2, 7. So it's like you have this line, and Q is down here, and P is up here. And this
Yes, mom.
perpendicular bias.
Where's that?
Please mute the mic. Alexander, mute the mic.
Yes, sir.
Class come, your mic is open. Mute your mic.
Oh, washroom.
Jesus. All right. So the line this question is asking us for is the perpendicular bisector. It passes through the midpoint. Remember, this is the midpoint that we just calculated a while ago. So it passes through the midpoint and is also perpendicular to PQ. So we're trying to find the equation of this red line, this perpendicular bisector. Let's just call it line 2 so we can reference it. The perpendicular bisector, we're calling it line 2 in this question. So we're trying to find the equation of that line 2. To find the equation of that red line 2, we need to know two things about it. We need to know the gradient of it, and we also need to know a point on it. The point we already know is a midpoint, because right here is a midpoint, so we have the point already. So it passes to the point M, which is this same point up here. What we need next is the gradient of this red line. Now, this red line is perpendicular to PQ. So it has a gradient that is the perpendicular gradient to PQ. Perpendicular gradient is a negative reciprocal of the one that you have. So let me show you what I mean now. So we're trying to find the gradient of line 2. The gradient of line 2 is minus 1 over the gradient of PQ. Now we already have the gradient of PQ up here. What was it again? It was negative 2, right? Negative 2. I'm going too far, Mr. Shaw. Negative 2. Right? So the gradient of PQ, let's write it here for a good measure. The gradient of PQ is negative 2. So it's like we'll take this negative 2 and put it under here for the gradient of PQ. In order to calculate the gradient of the red line is that perpendicular bisector. Or an easy way to do this calculation is to flip the one that we have and change the sign. So like we have negative 2 over 1, that's going to have this one. And to do this calculation, you flip it and change the sign. So when you flip it first, it will become 1 over negative 2, which is a negative value, and you will change this negative sign to a positive, and so it becomes a half. That's going to a half. But also, if you put negative 2 under here for the PQ, the negative will cancel negative and end up with a half. Anyway, you want to look at it, the gradient of that perpendicular line is going to be a half. All right, so let's put it in red. This is going to work out to be a half. So now we know the gradient of this line, and we also know the point, and it's the equation of what we want. So the equation of the line now, using what I call the BFF formula, is y minus the y value at the midpoint, the y value at this point, equals the gradient of line 2, the gradient of the red line, into x minus the x value at the midpoint. That gives you the equation of a line straight. When you substitute for these values that you should know, what are those values? This value is the y value at the midpoint, at the point, and this is the x value at the point. Let me put them exactly what they are. So this value is this y value at the midpoint. This value is this one, and then this one is the gradient right here. Substitute those values in, simplify it, and you have the equation. Simple like that. A lot of persons will go and use y equals mx plus c. If you use y equals mx plus c and calculate the c, no problem. Alright? Multiple ways to do this thing. Let's put in the values now. So the x and the y here represent your general point on the line. So your equation will come back in terms of this x and this y. Alright, so ready now. So it's going to be y minus the y value at the midpoint is 3. So put in 3 here. Equals the gradient of this line is a half. The perpendicular gradient is a half. Into x minus the x value at this point is 4. 4. Since this is a nice, this time this is going to give us a nice whole number 2, I can just expand the half across this bracket straight. So I'm going to have y minus 3 equals half times x is half x. And half times this negative 4 becomes a negative 2. Then I can take this negative 3 and bring it over here. It's going to become a positive 3 when I do that. And then positive 3 minus 2 is going to become a plus 1. Alright, so we're going to get a plus 1 with transpose the 3. So it's going to be that y is equal to then half x plus 1. This becomes the equation of the red line, and that's the answer right there. Half x plus 1. Let me take off this plus 3 over here. That's supposed to be there. But when we take this 3 over, it becomes a plus 3. 3 minus 2 is this 1. That's how we get the 1. But okay with that? Everybody understand?
Sir. Yes, sir.
Alright, beautiful. And that ends that question. Alright, I think today is going to be a nice, quick and short session. Just need to go and practice questions. Alright? Go and practice. Let me see what the next one was that I gave you. Let me see if I can find it. I know that this was the first one that I gave you, I think. 2017. Next one I gave you was 2022. 2022. So let's see if we can find that one. I think this is it. Alright, 2022. Alright, so I give it 2022. It's 2022 number 4B as well. Alright, this is the question. They give us a graph. Now, I like questions when they give it a graph. Like they give it the line here. But when they give it a graph, a lot of things you don't need to calculate. So some things we can pick up after just looking at the graph. So for example, I know the y-axis intercept on this line is 1 right here. So for this line, I know that C is equal to 1. I'm not showing you stuff that they can pick up. Then I can also count out the gradient. I don't have to calculate the gradient. So I can choose 2 points, for example, like for example here and here, and count out the gradient going from left to right, right? So the gradient is a rise over the run going from left to right. So what will be the rise? The rise will be this. The rise will be this. This will be the rise. And that rise is just 1 unit. And then the run would be 1, 2, 3 units to the right. So it's a positive run. So this is a rise. This is a run. Count them off. And so the gradient of that line would be rise over run between any 2 points. In this case would be rise 1 over run 3. So I know the gradient of that line is that. And if I know the C and the gradient, then I can just write the equation y equals mx plus c. So before I even start the question, I know the equation of that line already is just y equals a third x plus 1. That's it. The question asks that, and that's what the question asks us actually. Write the equation of the line. They say there's no calculation needed because you can count out the gradient and you can also see the y-axis intercept. So this that I did over here is actually the solution. Right? So I can say that the c is equal to 1 and put it in blue. And the gradient m is rise over run between any 2 points, and I've chosen these 2 points. Don't have to be these two. Any 2 points you choose. When you want to choose points where you can count exactly, precisely, accurately the rise and the run. And in this case, it is 1, rise 1 over run 3. And you put the c and the m in this equation. Right? Y equals mx plus c. So the equation is y equals the m is a third x and the c is 1 in this question. But good at that? Nice and easy. But good?
Yes, sir.
Yes, sir.
When they give you the graph, guys, the calculation gets a lot easier because you can see stuff on the graph, count up these things. You don't have to be doing a lot of calculations when they give you the graph. Alright? This one says no. The equation of a different line is this. Right? It says write down the coordinates of the point where this line is Q, right? This line is Q, they call it Q. And they say where the Q crosses the x-axis. So what do you know about the x-axis? On the x-axis, y value is always equal to 0. On the x-axis. And if y is equal to 0, it means that you're putting this equals 0 to find out what the x is. Right? The y is equal to 0, and this is the y. So the y is equal to 0 on the x-axis, it therefore means that the minus 2x plus 8 is equal to 0 on the x-axis. And you're solving this for the x. That is it. You're solving that for the x. So transpose the 8 and divide the negative 2. You're going to get x equals negative 8 over negative 2. That gives you 4. So on the x-axis, the x value is 4 and the y value is 0. So that point that on the x-axis becomes 4, 0. Understand that, guys? Understand that?
Yes, sir.
Yes, sir.
Good. So that's a point on the line, right? 4, 0. So I'm sure they're going to want you to draw it in. So let me put it down from now. So it passes through this point right here, 4, 0. That line at the one, pass through here. 4, 0. Alright. Next part asks us to write down the coordinates where it crosses the y-axis. On the y-axis, you know, said the x value is equal to 0. But it's easy, you know, because the line they give is y equals minus 2x. Is what they give? Y equals minus 2x plus 8. So this is the y-axis intercept. You should know that that is your c value. And the y-axis intercept is always 0c. Which in this case is 0, 8. So it crosses the y-axis at 8. But it's the coordinates. So you cannot just put 8. Coordinates is written like this. Coordinates is a plural word, plural S on it. Means 2 coordinates. I write the X and the Y coordinate. So if you give them the 0 and the 8, you cannot just write 8 alone. It says coordinates, plural. So this is the answer. If you just write 8 alone, that's not the answer. So it means that the cross the y-axis at 8, but the coordinates is 0, 8. So you can go up here and show where crosses the y-axis all the way up here. 0, 8. Right up here. So the line that we want now passes through these 2 points. And I'm sure they're going to ask you to draw it. Right? Sure. See? It says on the grid on page 14, draw the line Q. So to draw that line Q, all we need to do is just draw a straight line through these 2 points. And we have the point Q. But let me just show you something. Let me just take the opportunity and show you something. Let me move this gradient calculation further down here, out of the way. Let's move it down here, out of the way. So I'm going to use these 2 points for the gradient calculation, here and here instead. So it's kind of out of the way. So this will be the rise, and this will be the run. Okay, we can use any 2 points now. So the run is 3, and the rise is 1. Just the same, alright? So that's that. I'm using these 2 points to show the gradient. So example. So when I put rise over run, the examiner is knowing where I got the values from a 1/3. Right? That's what it is. Because I'm not using a calculation method, I'm using a graph. Alright, but let me show you something now. So the line Q is this. I'm going to show you now what I want to show you. The line Q is y equals minus 2x plus 8. Now with these 2 points, I can draw the graph, right? I can draw a straight line through these 2 points, and that's my line. I can do that, right? But let me show you another way we could have drawn this graph, this line, without plotting these 2 points, right? So when you have the equation like this, with y alone as the subject, you know that this is y-axis intercept 8, so you would know that point. Now, the gradient can be used to find other points, because gradient really is how you rise and run between points. So for this line, the gradient, the rise over the run is equal to negative 2. To make it into a fraction, I put it as negative 2 over 1. This means rise negative 2, run 1 to get from point to point. To get to the next point, I can rise negative 2, run 1, or to get to another point. Alright, so starting here, I could rise 2 units down. Now when the rise is negative, it means that you go down. And this run, which is positive, means that you go to the right. I'm going to show you that you can get from other point on the line. So starting here, I would rise 2 units down. That's 1, 2, and run 1. So it means that this is a point on the line, right here, that I'm marking in red. Then I could continue, rise 2 or more, down 2, go down 2 units, and run 1 to the right. And that's another point on the line. I could continue, rise 2 more units down, run 1, and so this is another point on the line right here. Then if I rise 2 more units down and run 1, you see that I end up back on the point on the x-axis. So it proves here that the rise over run works. Right? Now, I don't have to use these small rise and small runs, I can multiply this rise and run. So for example, instead of doing minus 2 over 1, I could put minus 4 over 2, double the jump. I multiply this by 2, I multiply this by 2. Right? Or I could use minus 6 over 3. Anything that is still equal to negative 2 can work. Or it could be minus 8 over 4. And get the same result. So look, if I use a minus 8 over 4, so instead of doing those like mini runs and rise, right, I could just rise negative 8, rise negative 8, run 4. So to rise negative 8 is to come down 8 units from here. That's 1, 2, 3, 4, 5, 6, 7, 8. Down to the x-axis and then run 4. 1, 2, 3, 4. I end up here just the same. But if you want to use the minus 2 over 1 and just go step by step, no problem. the end result is the same. Alright, so I just wanted to show you that you can draw the graph without putting the points. In any case, our line that they're asking us to draw is the line through here. Now I pass through this point as well, right? Right here. You did get that point as well. So you use your ruler and just draw the straight line now through here. And that is your line Q. That's a line Q. And they're telling us to draw. And you want to label it Q like that. That's a line. Right? And I'm sure they're going to ask you about something about this point. That's the point of intersection of the two lines, which is the point 2, 2. Right? No, 3, 2. Sorry, 3, 2. So this point is 3, 2. As you can see, this point of intersection at 3, 2. But generally speaking, if they give you something like this, they're going to ask you about that point of intersection. That's also how these questions are. When you practice a lot of questions, you kind of know what they're going to ask next, or what they're likely to ask. Let me see what they said. So we're drawing this line. I'm getting 1 mark for that. Here now it says, complete the statement below. It says, according to the graph, the solution of a system of equations consisting of line L and Q is the point of intersection. In other words, when you solve simultaneously the line L and the line Q, you're finding the point of intersection. And the solution will be the intersecting point. Right? And it will be the point. It will be the point, the solution, it will be the point 3, 2. This is the answer. That's what the question is asking for. According to the graph, the solution of a system of equation consists of line L and line Q. Meaning when you solve simultaneously line L and line Q, you're finding the point of intersection. And the point of intersection based on this graph that we draw is this point right here, which is 3, 2. So this question is asking for that point down here. Alright, so question like this, guys, when you redo it, if you never get all of this, you didn't understand it, or you go and do the question over again. Any questions on it? Any questions on this?
Sir, could you just go through that again? I had some internet problems and kind of blocked out for a couple minutes. Could you go back over?
Remember it is recorded. So it's a matter of going back over. You can watch the recording. I prefer to move on to another question, actually.
Yes. Yes, sir.
Right, I can go back over it because of that. If it was a case where you were on and don't understand something, that's different. But it is recorded. If when you watch the video, you don't understand something, you can let me know. Right, but I can't just go over it just because you had internet problem, because other persons are here as well. Remember, it's not me and you alone here. Right, so other persons who didn't have internet problem, anything you need clarity on? Anybody? Alright. So as I do the other questions, Alexander, you'll pick up, alright? And if you watch the video, as I said, this part of it, since you had internet problem while we're doing it, if you watch the video or you find something that you don't understand, you can let me know and I'll explain it for you. Alright, but let us move on to the next question. Alright, the next question was, let me see. Next question was, I think this one, another graph one. This one was January 2023, and this one showed 2 lines now. Alright, let's see. Let me see. Alright, January 2023. Good. This is question 4. Alright, that's another quadratic geometry question. And as I said, it's always a lot easier when they show you the graph, they show you the lines on the graph. It means that you can basically answer everything from the graph. So for example, for this line L, we can see the y-axis intercept is 3, and we can count out the gradient. Right? For example, we can choose 2 points on the line L, like for example here and here. And going from left to right along the line, you count the rise and the run. So in this case, for line L, the rise is 1 unit down. That's a -1 rise. And I run 2 units to the right. So line L, the gradient of line L, capital L, would be rise -1 over run 2. And the C for line L is equal to 3. That's line L, you know. So Although doing any work, the equation is y equals m. This is the m. This is minus half x plus c. C is 3. Without doing any work, that's the equation of line L. Just like that. Let's talk about line M now. I'm just showing you what you could do. This was line L. If we're doing line M now, again, you can see that the y-axis intercept down here is -2. So for line M, the C is -2. It's line M now. Line M. The C is -2. And we can count out the gradient. Now we can choose 2 points for the gradient. For example, here and here. Going from left to right. This one is sloping upwards. So there's a rise of 2 units. See? That's a rise of 2. That's a +2. And a run of 1. So for this one, the gradient would be rise 2 units over run 1 unit. 2 over 1 is 2. Right? So the equation of line M would be y equals this gradient times x. And then the C is -2. That's the equation of the second line, line M. Just like that without doing any work. Right? And you can see that 2 lines perpendicular. I know that perpendicular. Because when you multiply the 2 gradients, this gradient times this gradient, you multiply these 2 gradients of the 2 lines. 2 times -half equals -1. When the product of the gradients is -1, it means that the lines are perpendicular. Right? I don't start answer the questions yet, but I know all these things already. And then this now is the point of intersection of the 2 lines right here. That's a point 2, 2. So if you ask anything about the intersection, it's a point 2, 2. Alright, so let us answer the questions. I just wanted to show you how easy these questions are. When they show you the graph, you can see a y-axis intercept, you can count off your gradient. It just becomes very easy. These, right? You don't have to be calculating a lot of stuff. Well, let's answer the questions now. Let's answer what they want. Okay, not just putting what we want to know, it's answering what they want. Alright, this one says that write down the coordinates of the x-axis intercept, the x-intercept with L. Right? This is talking about this point right here. This is the line L running down here. I want the x-intercept, which is right here at 6. That's 6, 0. Just write it down. You don't have to calculate anything. X value there is 6. Y value there is 0. You cannot just write 6. Or it says the x coordinate. Right, write on the coordinates of the x-intercept, right? So you have to write coordinates plural. So you have to write both of them like that. The x value and the y value in the bracket, you have to put both of them because coordinates is a plural word. It means you have to write both of them. That's the answer for that one. Alright. Next part asks us for the y-intercept of M. Now M is this line now, this one. And the y-intercept is right here at -2. Again, that's just a y value. Y equals -2. But there the x value is 0. So that point is 0, -2. Right? This is referring to this point right here. 0, -2. So far so good. Sorry, student, sorry. But understand that so far? But okay with that?
Yes, sir.
Alright, good. That's what this I want us to do. It says the equation of line L is this. So they give us the equation of line L. Alright. It says find the value of K such that the point 9K is on L. No, there are 2 ways we can do this. We can do this. And what happens is that K is the Y value when the X value is 9. And the X value is 9. So you can substitute those 2 values in the graph, in the equation, and find the value of K, Right? If the point is 9K is on the line, then you can substitute the values in the equation of the line. It means that the point satisfies the equation of the line. You're free to plug those values in the equation of the line and work out itself. Right? Because a point on the line, that's what they said. So if you substitute the line, if you substitute the point into the equation of the line, then the x value is 9. You're going to get 9 plus 2 times the y value is k. So it's 2 times k minus 6 equals 0. And you're solving this for the k. Well, the 9 minus 6 is 3. So you get 2k plus 3 equals 0. Right? And then now you transpose the 3 and divide the 2. So you're going to get the k equals minus 3 over 2. Or minus 1.5. K equals minus 1.5. Another way you could have done it is to see if we can find this point on the graph where x equals 9 on the graph and see what the y value is on the graph. You know it as well on the line L. Let's look if we can figure it out. So on line L, we're going to see where x equals 9. What is the y value at that point where x equals 9? Let's look at the graph and see if we can pick it up. Alright, this is the line L we're talking about, right? And here is where x will be equal to 9. See? Right here. 7, 8, 9. So right here is where x equals 9. So this is the point they're talking about, where x equals 9. So that point is 9 something. What something? See here, this is negative 1. And this is negative 2. So this is halfway between negative 1 and negative 2. That's negative 1.5. So that's negative 1.5. So the point is 9k. And the k is negative 1.5. Same answer that we got. So whether you want to use a graph to do it, or you want to use calculation to do it, that is it. K is negative 1.5. Want to go to that? Right, okay?
Sure.
Alright. And this one now says, find the equation of line M in this form. Line M. I think we did it already. So, for line M, we saw that the y-axis intercept was negative 2. Alright, the c is negative 2. And then the gradient, which is rise over run, let's count it off. Rise over run becomes equal to, what was it again? Okay, rise and run between any 2 points. I think we used these 2 points a while ago. Here to here. So we rise 2, and run 1. So the gradient is 2 over 1, which is 2. The gradient becomes 2 over 1. Rise 2, run 1, which is 2. So if you know the C and the M, you can put them in this. So the equation of M is y equals, the M is 2 times x plus c, and the c is a negative 2, so you can write minus 2 here. And that's the equation of line M. Alright, next part says, show by calculation that line M and line L are perpendicular. Same thing. To show that they are perpendicular, to show that the product of gradients is minus 1. So when I record the gradient of line L, I think it was minus half a while ago, right? So I'm going to put it on this graph so the examiner know how we get it, you know. So I'll come here, so again, I'll find 2 points. You can use this point and this point. And it's a rise negative 1. And I run 2. So gradient of line L is rise negative 1 over run 2. So see it here. Gradient of line L, where is it? Is rise over run between those 2 points is minus 2. No, it's minus 1 over 2. Minus 1. Yeah, rise minus 1. Minus 1 over run 2. Minus 1 over 2. Rise minus 1 run 2. And the gradient of line M, worked out to be 2 a while ago up here, so here is 2. And so we're gonna say now ML, I can say since ML times MM, that's the greater of line L times the greater of line M, is equal to minus half times 2, which is negative 1. So the product of the gradients is negative 1. Since that is the case, since product of gradients equal minus 1, it means that L and M are perpendicular. That is it. We show that when you multiply the gradients you get negative 1 when the lines are perpendicular. Alright? Down here now is asking about the point of intersection. It says the lines L and line M represent the graph of simultaneous equations. Using the graph on page 11, that's the same graph we're working with. Write down the solution of the pair of equations. It's the point where they intersect. It's the intersecting point between them. So we solve them simultaneously. You're finding this point of intersection, which is 2, 2. Right? 2 is the x value, 2 is the y value, 2, 2. So that is 2, 2. The way you work it out, let's write it down. It's 1 mark for it. So that point is 2, 2. And that's the answer for that one. But okay. So that's this one as well. But good? Alright. Let's move to the next one. I wanted to redo these questions. Anybody didn't get in it? Anybody who didn't do it? Or you did get something wrong? You need to go and do it. Alright, you can't just watch me do it. Watching me do it is not enough. I'm telling you. Alright, watching me do it is never enough. You have to go and do it yourself. Alright, the next one is this one. 2021, January. Question 8, part A. Alright, another coordinate geometry question. So this question says, just give us this straight line. And it says intersect the x-axis at P and intersect the y-axis at Q. I want you to determine the points P and Q. Let's write out what I said. Now, let's look at it. Let's break it down. On the x-axis at P, the y value is 0. On the y-axis at Q, the x value is 0. So I have to remember. Alright? So at P on the x-axis, the y value is 0. Once the point is on the x-axis, the y value is 0. And on the y-axis, the x value is 0. Alright? And you have to work out what the other value is. So let's go. Let's do this one first. So at P, on the x-axis, the y value is 0. So you're going to take this y value of 0 and plug it inside here. So you're going to get x equals 5 minus 3 times 0. 5 minus 3 times 0 is 0, so you're getting x equals 5. So it means that at P, the x is 5 and the y is 0. So therefore, P is a point 5, 0. Just like that. Let's do Q over here. At Q, right here, the x value is 0. So at Q, because on the y-axis, x value is 0. So it means we're going to take the x value of 0 and put it in right here in the equation. So you're going to get 0 equals 5 minus 3y. And you're trying to find the y now, right? So what we can do is take the 3y and bring it over this side, make it positive, and get 3y equals 5. And then you take this 3 and divide it under the 5. So you get y equals 5 over 3. So at the point Q, the x value is 0 and the y value is 5 over 3. So therefore, Q is a point 0, 5 over 3. Those are the answers. And I want to put them here. So I want to put the 5, 0 here and the 0, 5 over 3 here. That's it. Are you okay with that?
Yes, sir.
Alright. Question now says calculate the length of PQ given answer to two decimal places. The length of PQ. Now, let me show you something now. For the length of a line, I would normally use the square root of the difference in x squared plus difference in y squared. That's how we used to get the length of a line. Alright? But if you notice here, the difference in the x is just 5 minus 0, which is 5. And the difference in y is just 0 and minus 5 over 3, which is just still 5 over 3. That's different. Now, why is that? You can look at it this way. If I were to sketch these 2 points on a graph, I should show you something. Right? The point Q is on the y-axis up here, and the point P is on the x-axis out here. And we're talking about this line. That's the line that we're trying to find. If you look at it, this distance out here is this 5, you know. So this length is 5 right now. And this distance up here is this y value, 5 over 3. So up here now, this is 5 over 3 right now. And this y-axis and this x-axis, they are at right angles to each other. It's a right angle. So you have basically formed a right angle triangle inside here. And the question is asking for this length. So if using Pythagoras theorem, we're going to get the same thing. It becomes the square root of 5 over 3 squared plus 5 squared, or the other way around. Square root of 5 squared plus 5 over 3 squared. So anyway you want to look at it, you're going to get the same thing. So let's call this length PQ. Right? The modulus of PQ. That means the length of PQ. So the modulus of PQ means the length of PQ. The way you put the modulus around it, it means the length. I could just write PQ as the same. It becomes equal to the square root of this becomes 5 squared plus this becomes 5 over 3 squared. And that's what we're working out. And I want the answer to two decimal places. Let me see if I can get the calculator to do this. Let's see. Let's get the calculator. And let's put this in the calculator and work it out. Here. Alright, so this becomes square root of 5 squared, which is 25, plus 5 over 3 squared, which is 25 over 9. I can just put 25 over 9 now. Well, let's put it as it is. 513 squared. And the answer is 5.27 to two decimal places. 5.27. We calculate length in coordinate geometry, you have to use the word units. That's unit of measure in coordinate geometry, units. That's it. But okay with that?
Yes, sir.
Alright. What is it? Anything else? It says R is the midpoint of PQ. The ones that determine the coordinates of R. Remember, the midpoint is like the average point. Alright, so it's right here. R is located right here. Right? So basically to get to that point is half of the 5 and half of the 5 over 3. That's it, you know? Simple as that. It's the midpoint. There's half of the 5, half of the 5 over 3. And you want to use the average again. The average in this 5 and this 0. And the average in this 0 and this 5 over 3. Average of the x and average of the y. So number is 5, 0. And 0, 5 over 3. Right? So R is midpoint, so R becomes the average of these two values, which is 5 plus 0 over 2, and the average of these two values, 0 plus 5 over 3 over 2. So R is a point. It becomes 5 over 2 straight, or 2.5, and it becomes 5 over 6, because if you have, it becomes 5 over 3 now. So if you have 5 over 3 divided by 2, you can take this 3 and multiply it under here. Right? Or you can say, okay, this 2 under here is same as 2 over 1. So you invert and multiply, and it becomes 5 over 3 times 1 over 2. So you get 3 times 2 over here. But I'll show you more on this some other time. But the answer becomes 5 over 6. As a midpoint, right? As a midpoint. Alright? As I said, you could look at it this way, and thus the midpoint, to get to the midpoint from the origin, half this distance, which is 5 over 2, and then half this distance, which is half of this, which is 5 over 6. 5 over 6. So you can get to R that way as well. Alright, like when they give you diagrams, you have diagrams sometimes. Diagrams show you a lot of the time what you need to do. But that is it, guys, for that question. Again, you never do it, go and do it over. Go and do them over for me, please. But alright with this one? But okay? But okay
Yes,
with
sir.
this? Alright, let me see which one we have next. Let's see which one we have next. This. Alright, this one from 2019. Alright. This question says, the equation of a line is given as this. This is the equation of a line, right? It says, this line crosses the y-axis at Q. So remember now, on the y-axis, remember now, on the y-axis at Q, the x value is 0. So to find the y value, I'm going to put the 0 in it right here. And it says, determine the coordinates of Q. So, that is it. At Q, the x is equal to 0. So this becomes 0. So the equation becomes 0 over 3. I'm going to put the 0 right here. Plus y over 7 equals 1. So it's gone. So you're left with y over 7 equals 1. Multiply by 7, you get y equals 7. So Q is a point 0, 7 on the y-axis, 0, 7. Alright. Next part says, what is the gradient? So to get the gradient, what we can do is transpose this into the standard form, y equals mx plus c. Let's look at it. We have x over 3 plus y over 7 equals 1. Alright? We want to get it in the form y equals mx plus c. You know, we want y alone to be the subject. So I'll take this x over 3 and bring it in front here first. Try to make it look like that. So we're going to get y over 7 equals be equal to x over 3 plus 1. Well, actually, minus x over 3 plus 1. Okay, bring it over, it becomes a negative. We need to multiply by this 7 on here. Multiply through by 7. We multiply through by 7, and put it down here. Multiply through by 7. This becomes y equals minus 7 over 3x. Can I see this x over 3? Let me write another way for multiply by 7. It's same as y over 7 equals minus 1 over 3 times x plus 1. To divide by minus, to divide by negative 3, or to divide by 3, to divide by 3, right here, is the same as to multiply by a third. Then this minus is this minus. But I'm trying to get it to look like this. I need to now get rid of this 7 by doing this multiply by 7. So then write it over. I multiply it by 7 now to get the y under the subject. Multiply this by 7, it becomes just y. Multiply this by 7, it becomes negative 7 over 3x plus multiply this by 7, it becomes 7. So the y-axis intercept is 7, and this is a gradient. So gradient m equals minus 7 over 3. But after that, very good.
Yes, sir.
What else I want us to do? Oh, done. That's all I wanted. That's all I wanted in this question. Nothing else. Alright. Let me see what else was there. So to the class really short. But the hour, which is good. That is fine. Just need to be practicing, guys. Practice. And so the last one is 6% already. No, we have another one to go. Let's see. I got one more. Call it a day. A nice, quick, spicy session today. That's okay. Not all the classes are gonna be lengthy. Where is it? What's that? 2018. This is 2018. I love it. 2018. Find if I can find it here. Let's see if I can find it here. Let's see. 2019. 2018 is January. This is it. Alright. That's the last question we're doing for today, guys. Alright, 6 nice and easy questions. You just need to practice. You just need to practice. One way to practice, you redo the same question that I'm doing. Let's do them again. Watch back the video to give yourself some assistance. Alright. Alright, here we go. Alright, this one says the equation of a straight line is this. So write the equation in this format. So in other words, transpose to make y alone the subject. That's what I want us to do. Alright. So first thing I'm going to do, I'm going to take this minus 4 and bring it over this side. I take this 5 and bring it over this side. Alright, look, notice I'm going to have 3x, minus 5 equals 4y. Alright, so that's what happens when I take this over to the right side. It becomes this 4y. I want to get the positive, take this 5 over this side and get this. That's not the only way to do it. You have to get rid of this 4, so it's divide through by 4 or multiply through by a quarter. So whichever way you want to look at it, I divide this by the 4 and divide this by the 4, each of them. So I divide this by 4, divide this by 4, divide this by 4. Alright, so I'm gonna get that y is 3 over 4x minus 5 over 4. All we have to do is turn it around. Make this be on the left side. So y equals 3 over 4x minus 5 over 4. That is in the form y equals mx plus c. Are you okay with that?
Yes, sir.
Okay. They said determine the gradient. The gradient is this. Right? So the gradient is m equals 3 over 4. That's it. That is it. The gradient is m equals 3 over 4. This is the m. Alright. Then they said now the point P R2 lies on the line. Determine the value of R. Simple. I take these values. You can put it back in the original one up here and you don't have to work with this, you know. So remember we had 3x. Let me write it back down here. We had 3x minus 4y equals 5 originally. Right? And we want to find this. We can take this x r and put it here for the x. And then take this 2, which is the y value, and put it here for the y. So we're going to substitute the point in the equation because the point is on the line, so it satisfies the equation. So we're going to get 3 times the r, we put the x equals r right here, minus 4 times the y value, then is 2. We're going to put the y value of 2, that equals 5. And you're solving this for r. This is minus 8. Minus 8 goes over there and becomes a positive 8. And 8 and 5 is 13. So what we're going to get next up here is that 3r equals, and as I said, this 8 goes over and to 5, give me 13. Then divide both sides by 3 to get rid of this 3. Or you can say take this 3 that is multiplying and divide on this side. And then we want to look at the r equals 13 over 3. That's his answer. Alright, next part says now find the equation of a straight line passing through this point which is perpendicular to L. Now what is the gradient of L again? The gradient of L is 3 over 4. We're trying to find the perpendicular line through this point, right? See? It's a find the equation of a line passing through this point, that is a point, which is perpendicular to L. So because I want the perpendicular line, we need the perpendicular gradient. We need the perpendicular gradient. Let's call this line 2. Let's call this line that I want line 2. Let's call that line 2. So the gradient of line 2 is minus 1 over the gradient of line L because they're perpendicular. This calculation on the gradient of line L is done by simply flipping this line L gradient and change the sign. It becomes minus 4 over 3. And it passes through this point. I'm going to call the point that it passes through that we know 6, 0. Let's call it P. So we can reference it. Alright, so the equation of line 2 is y minus the y value at the point here equals the gradient of line 2, which becomes negative 4 3 into x minus x value at this point here, P, calling it P. Plug in the values, y minus the y value at the point is 0 equals the gradient is minus 4 3 into x minus the x value at the point here is 6. So this side just remains y equals, expand this now, the minus 4 3 times x minus 4 3 times x. Then this time, this first is going to become a plus because the minus times minus is a plus. Then this 3 into this 6 is 2, and then 4 times 2 is 8. Plus 8. And this right here is the answer for this question. Any questions on that? But okay?
Yes, sir.
I think we're done. It's a different question. This is something I'm moving on to next. Inequalities, linear programming, linear inequalities, and so on. But that is it for today, guys. You got a nice, easy day today. Can't quarrel. Can't say Mr. Shaw never give you an easy short class yet. How long was it? just about an hour or less, which is good. So nice quick session today. We did 6 questions and that is it for today. Just need to go and redo the questions. Those who did it and get anything wrong, or if you did not do it, go and redo them. We're gonna do the classwork tomorrow on this topic. So you come to class tomorrow on Monday, I want to practice a few more questions and then I'm going to give the class activity. I'll be done with it tomorrow. Move on to linear programming on Wednesday, Thursday. Alright guys? Very good?
Yes, sir.
Yes, sir.
Alright then. Bye bye buddy. See you in class.
All right, sir.